ladies and gentlemen. I'm going to talk with us about how we can find the velocity of a ticker tape diagram, and I'm going to give us a quick refresher on how we can find an angle, the angle that velocity is traveling at. So to start with, let's just have a look at a situation where we've got two objects, they collide, one goes off in one direction, one goes off in the other direction. So what this would look like from a ticker tape situation is we have our dots. Here they go. Here's our ticker tape. There's the first object. All right, traveling along, then it slams into another object. Now this object's been stationary up until now, so it's got a whole bunch of dots right there. But after the collision, this object flies off in that direction. And the other object goes off in this direction. So when we want to find the velocity of both or one of these objects, we need to know a couple of things. First, we need to know with what frequency these dots are being made. Thankfully, we've got most of the technology we're going to be using has ratings on it, often with this wonderful Hz. What does that mean? It means hertz. And what hertz are is cycles per second, which in the case of ticker tape diagrams is, that's right, you guessed it, dots per second. Great. So we can definitely use this information to help us figure out how fast these objects are going. So to start with, what is velocity? Well, velocity is our distance over our time. So what we're going to need to use is we need to use this ticker tape to find a time and the distance that was traveled in that time. Well, the distance that was traveled in that time isn't that difficult. All we need to do is grab a ruler and measure it. So there's my ruler. I've got those two lines there to help me figure this out. And looking at that, look at that. As luck would have it for me, it's about 6 centimeters. So I'm just going to put that over here. My distance is 6 centimeters. Now, the one thing that I know can get me mixed up sometimes, and so I don't want it to happen to you folks, is units. Often people forget to convert them and have them in one unit when it should be a different unit, and it gets crazy. People get confused, they get lost, and then they have no idea where they are. I don't want that to happen to you. So, what I like to do, I like to convert anything that's not meters into meters. I like to make sure things are in seconds. I like to make sure things are in kilograms. So here, we have 6 centimeters. I want to convert that right off the bat to meters. Thankfully, I know that conversion pretty well. There we go. So I'm just going to put a nice little box around that for now. That's something that I want to keep track of. Why? Because it's going to end up in my velocity there. Next, how am I going to figure out how long it took for my object to travel that 0.06 meters? Well, it's not that difficult. All I need to do is count some dots. All right, so there's 1 dot, there's 2 dots, there's 3 dots, there's 4 dots, there's 5 dots. So it traveled 5 dots in 0.06, or traveled 5 dots, which was 0.06 meters. So I've got 5 dots. Now, if you remember when we were working on conversions, if I want to get rid of dots and I want something to be seconds, I need to multiply this by something that's going to have seconds over dots. That way my dots are going to cancel. Well, wait a second. Hertz is dots over seconds. And if we check our machine, in this case, I'm going to say that the machine says we're at 60 hertz. So I just flip that. It's got 1 second over 60 dots. That's not bad. Cancel out our dots, and we're left with the time. That time is going to be 5 seconds over 60. But let's not just leave it like that. Let's plug it into our calculator. Make sure we get a set number here. So I got 5 seconds divided by 5 by 60. My time is 0.0833333333333. Great, got a time. And that's of course in seconds. So I've got time, I've got distance. I'm going to put another box around this one. Brilliant. There's my time. There's my distance. I know my velocity now. All I do, my distance is 0.006 meters, and my time is 0.083 seconds. This gives me a total velocity from that bit there of, well, let's see, 0.06 divided by all of that, 0.72 meters per second. Great. Got our velocity. I'm happy with that. So I'm going to put some stars there. I'm going to celebrate a little bit. Great. Because with this now, I won't go into this in detail, but with this now, you can find the momentum. But that's great. Now we can follow this exact same method to find the velocity of the other segments we've got going on here. But where some people might get a little bit confused, because I know it was a long time since I used some really fancy, over-the-top technology to find angles. Might have been some time since you used these wonderful devices too. So what we want to make sure we do is, I like to draw a line that follows along here. That way it gives me a kind of a baseline. And equally so, just for sake of ease, I'm going to draw a parallel line that's going to go through there. That way I can make sure I get my angles correct. And then what I'm going to do is I'm going to pull out one of the most advanced pieces of technology anyone has ever seen. That's right, you see it here first. It is the protractor. So now all I'm going to do is I'm going to line up this line along the bottom here. I got to do this to make sure that everything reads accurately. That is an important step, folks, because if we mess that up, we can very easily get the wrong angle. So do keep that in mind. And then I'm just going to read my protractor, which I've a little bit off here, but I can just move it over to make sure that I've lined up properly. Like I say, you got to be careful of that. Lining it up, in my case here, happens to be about 50 degrees. Great, so we've got that one. Now we need to find this one. So there's a couple different ways we can rotate this so that we're parallel there. Let's rotate a little bit more. There we are. Now I'm just going to, again, have a look at it here, see where things line up. And this one is approximately 33 degrees. So we see now we can find our velocity of this line here. We can find our velocity of this line here. And once we've found those velocities, we can also find their momentums. But with this, we also know the direction that these velocities are going at. So I'm hoping that that will help you significantly whenever you're dealing with ticker tape diagrams and collisions in 2 dimensions. I hope this helps a lot, and have a great afternoon.